Good morning, everyone. My name is Michelle Dalton. I am from Testing for Keys. I'm one of the co-founders there from Portsmouth, New Hampshire, and thank you, Sylvia, for that wonderful call out. It is my pleasure this morning to introduce the keynote speaker, who is Dr. Linda Birnbaum. She is the director of the National Institute of Environmental Health Sciences and the director of the National Toxicology Program. She is a board-certified toxicologist and has served as a federal scientist for over 37 years at both the EPA and NIEHS. Dr. Birnbaum is a former president of the Society of Toxicology, which is the largest professional organization of toxicologists in the world. She is the author of more than 800 peer-reviewed publications, book chapters, and reports, and is an adjunct professor at several universities, including Duke University and the University of North Carolina. Dr. Birnbaum has received many awards and recognitions for her exceptional work, including being elected to the Institute of Medicine of the National Academies. She has received the Women in Toxicology Elsevier Mentoring Award and the EPA Health Science Achievement Award. Dr. Birnbaum's research focuses on the pharmacokinetic behavior of the environmental chemicals, mechanisms of action of toxicants, including endocrine disruptors, and linking the real-world exposure to health effects. In particular for our conference here, Dr. Birnbaum has been a leader in advancing the science of PFASs as well as translating it into everyday world. For example, working with furniture manufacturers to change product formulation to be one that is more health-friendly. Most recently, Dr. Birnbaum has been heavily involved in working with New York Senator Gillibrand in support of PFOA research for Hoosick Falls and Petersburg. Last July, Dr. Birnbaum came here to Northeastern University to visit with the Superfund Research Program in Children's Environmental Health Center and gave a very well-attended public lecture. We are honored to welcome back Dr. Birnbaum to Northeastern University today.
So, first of all, thank you all. Michelle, thank you very much for that lovely introduction. I'll give myself all. And I'm going to be able to go very, very quickly through some of the beginning of my slides because we've already heard some of them. In fact, some of them are identical to the ones that we've already, that Laurel showed. But I just did want to mention that working with PFAS is nothing new for me. I actually published 3 papers in the 1980s where I was looking at the C10 carboxylic acid, PFDA, and I showed at that time that only a 10-day exposure in utero was associated with a reduction in fetal weight at 0.1 mg per kg, which is a very, very low dose to the animals. And that work was all published, as I said, in 1989. And it's like what goes around comes around. So I just wanted to show a little bit about some of the changes in production that are going on with some of the perfluorinated compounds. And one of the points that really here is, while we may have really not producing as much as we did here in the US, look what's happening in China. And of course what we all know is that, global is local, and whatever is produced in China ends up here in a relatively short amount of time. If it's emitted into the air, it's only 4 or 5 days before it hits California. And so we need to be aware that it's not only what we can do in this country, but has implications for what we need to do worldwide. Now, there are a whole bunch of chemicals of concern, and we're going to be focusing on the perfluorinateds today. But I just want to remind you that sort of like the perfluorinateds, we're still dealing with the legacy of PCBs. And we're going to be dealing with the legacy of the perfluorinated compounds, not for the next 10 or 15, but for the next 100 or more years. 70% of the PCBs that were ever made, these were banned in 1977 in the US, are still out there. Certain things are never going to go away. Mercury is a natural element, okay? And it gets converted into highly toxic forms. Arsenic is up there. For example, pesticides, how to put a dioxin, since that's one of my favorites. But again, we all carry a legacy burden of it. But what we want to talk again about today is the per and polyfluorinated alkyl substances. And again, we've had a really good introduction about this from Laurel, that the PFOs and the PFOSs and the structures on the bottom, Laurel can show the same thing. And the point is that we really need to we may have these 3,000, in fact I'm hearing from some of my EPA colleagues, there may be more like 6,000 different perfluorinated compounds that you can actually find out there in the environment. Many of them actually break down to give you PFOA and PFAS, that these are the terminal breakdown products. So in the atmosphere, you end up going to PFOA and PFAS, and the PFOA and PFAS essentially are never going to go away in our environments. So again, we've heard some of the introduction for the levels of PFOA and PFAS, that the U.S. production of these two, PFAS was really, 3M was the sole U.S. manufacturer and stopped making it in 2002, but of course we still have it. PFOA, we have this voluntary reduction, is no longer being made, but again, still out there. And we saw that the very slow half-lives in human. The point I wanted to make at the bottom is that while, for example, the actual levels in people of PFOA and PFAS have gone down somewhat since large production stopped, it's not going to go to zero because it's still out there in the environment, so it's still going to be recycling, as well as I said that we have the breakdown products. So, contaminated communities across the U.S., and these are just a couple of recent headlines in the papers, so you see Hoosick Falls up there. Up in your right-hand top corner, that the CFPUA, that's North Carolina, my state, has huge productions. That Gen X that was shown before is made in tremendous quantities, released into the Fayetteville, into the Cape Fear River, and we've got really high levels of contamination, and Andy Lindstrom is here and can fill in on the very high PFAS contamination we have. But the point is when EPA gave that new advisory level of the total of 70 parts per trillion of PFOA plus PFAS in drinking water, at that point they said there are 6 million Americans who are exposed based upon above at 70 or above based upon that new advisory limit. But we now know from, again, some of the work that's just come out from Northeastern that there may be many, many more people than that exposed, maybe not to the regulatory limit, some may be lower than that, but they're still being exposed. And since these are chemicals that build up in our bodies, what you are today is a reflection of what you've been for the last 10 or 15 or 20 years or more, and I think that's something important to remember. So this is just a little bit data, Michelle, from Peace, just showing that your levels are elevated, your blood levels for PFAS, PFOA, and I thought it was really interesting the PFHXS, because that C6 is something that has been a major replacement for PFAS, and at least we've been told that, oh, this one doesn't bioaccumulate and this one isn't toxic, and the answer is, I have a bridge in Brooklyn if you want to buy it. It's the same kind of thing, and we are seeing that increasing in the population. These are just some examples around the Air Force bases, and we know from some of the work about the firefighting foams, the AFFFs. So anywhere you have an Air Force base, you're likely to have elevated levels. And then this slide that was just recently shown, I think is very important for seeing watersheds where you have a point source, you're going to have higher detection frequencies. And again, while our focus at this meeting, and we're talking a lot about point sources leading to contamination, you can also have non-point sources, for example, from the biosolid application and so on, which can also lead to contamination. So just a nice little slide to look at the exposure pathways, and I'm not going to go through the whole thing, but the complexity of the exposure. Obviously, since these are totally synthetic chemicals, there is no natural production of PFAS, unlike, for example, some of the dioxins which can be produced by volcanoes and forest fires. Okay, for example, the PFAS are being an industrial product, and they're released into the environment, and then they can circulate many ways and get into people. And again, we're focusing on drinking water as a major route of exposure here. I want to remind you that there are other routes of exposure, such as food. So the study that was released last year showing the fluorinated compounds in fast food packaging, I think is important, that at least half of the fast food packaging that was looked at had elevated levels. Again, Laurel showed us some more data about that, but the point is this going to also have an issue related to environmental justice? Are we going to have our people who are most disadvantaged, most exposed because of this route of exposure? And we really haven't done very much looking at food as a major source of exposure. And this is where it migrates from the packaging into the food, but I would tell you that also, for example, fish that are happily swimming in water supplies that are contaminated are also going to be contaminated. And at this point, there are no fish advisories based on perfluorinated contamination of fish, which is something we should begin to be thinking about. So we're going to have a whole session in a little while about the wide range of health effects of PFAS, and this is just giving you an example of some of them. I mean, have your pick: testicular cancer, kidney cancer, GI effects. Lipid is a clear target, so there's often high cholesterol, hypertension during pregnancy, impacts on the thyroid gland, other hormonal changes, impacts on liver, obesity, immunotoxicity, and I'm going to come back to the immunotoxic effects, lower birth weight and size, delayed puberty, decreased fertility, early menopause, reduced testosterone, prostate cancer, ovarian cancer. What else would you like to throw in the mix? I mean, this is kind of a multi-target carcinogen and toxicant, depending upon who it affects, when it affects you, where it affects you, you may have different responses, but there's a very, very wide body of responses that have been seen. So Phil asked me to talk about, for example, how does an EHS decide what it wants to spend its $800 million budget on? And I should say that we are very thankful that we did not get any cuts this year. We got a very tiny increase. Projections for NIH as a whole next year is a 27%. The request in the president's budget is for a 27% decrease in funding. We don't think that's going to happen. We're pretty confident it's not going to happen, but we don't know whether we might get, thank you, some cuts. It's very important that we can all educate our representatives to the important work that gets done. But anyhow, we have a strategic plan which has many, I often call kind of the rotating thing, because you can't do environmental health sciences without doing it in a multidisciplinary, transdisciplinary way. You can't do it without getting the communities involved. You have to go all the way from the basic sciences to the translational sciences and exposure. We have to deal with our disadvantaged communities and our global interactions, and we have to, all, as I said, all work together. Now, there are kind of different kinds of work that we have. We have much of our grants program, which, like any NIH institute, is the largest part of our funding, and much of that is investigator-initiated research, where we receive grant proposals and then fund them. We also fund a lot of centers in order to have a more coordinated effort as well. The National Toxicology Program, which is a cross-agency organization headquartered at NIEHS, but also involves parts of CDC and FDA, works by nominations. And the nominations can come from anybody. So we have nominations from individual citizens, we have nominations from industry, we have nominations from other parts of government, we have nominations from advocacy groups. If you see things that you want studied, for, tested for what their impacts may be, just go on our website and there's a nomination form and fill it out, and we'll be looking at it. We also get information from our government partners, for example, so the NHANES data that provides biomonitoring information that tells us what levels are of things that we know about. And of course, we have a whole effort under our exposure and exposome program of trying to understand what's out there that we don't know about. Because when you do biomonitoring, you're looking under the lamppost. You're saying, what is present? This is what I know and this is what I look at. Well, how do we know that all those other things that we don't know about might not be having an impact? So we're doing agnostic approaches as well to monitoring. And as I said, we work with our agency partners. Now, currently we are funding about $10 million a year in work involving the perfluorinated compounds. I don't think that the alphabet soup here is very helpful for you unless you're a grantee, and then you know that the PO1s and the RO1s are basically all investigator initiated. The P42 is our Superfund Center. We have one here, for example, at Northeastern. And then, for example, the UO1 is a collaborative agreements in which the grantee works closely with their federal partners in order to conduct their research. So at the moment, we're funding about 32 different grants looking at perfluorinated compounds. And they have a wide range of topics that many of them are dealing with human sources and effects. In fact, the majority where we're looking at exposure from waterhouse dust and diet, and looking at a variety of endpoints. And these are all things that I mentioned in that long list: impacts on birth weight, fertility, reproduction, and so on, endocrine disruption. Some studies looking, for example, There have been a number of studies that have shown association between elevated in utero exposure to perfluorinated compounds and ADHD, for example, cardiovascular disease and immune outcomes. In our animal systems, we are studying not only rats and mice, but we're also doing lots with zebrafish. And for those of you who are not into the field, I can tell you zebrafish are a great animal model to be using. You can study them. Individual zebrafish, their first 5 days of their development, they are totally transparent. And so you can actually watch the heart forming, the brain forming. It's very, very, very cool. And again, you can look individually. We can put 396 zebrafish, one into each well of a plate, and quantitatively measure what's happening with a large number of samples. And they are vertebrates, so that we can look at a lot of the same things that we can in ourselves. Nature's very, very good. We also do a lot of in vitro studies, and I'm going to come back and mention some of those later as well, looking at a whole number of endpoints, but we are looking at, in our animal studies, at cancer and genotoxicity in vitro, looking at things like gene expression changes and signaling pathways and so on. So some of our grants that we're looking at to examine perfluorinated compounds, and looking at the health, we have a large study, which is a prospective longitudinal study. It's a birth cohort that was started in Cincinnati. This is largely a study involving Caucasian mothers and children, but we've been following them now. These studies started about almost 10 years ago, and we have 400 infant mother pairs, and we're looking at developmental and behavioral outcomes, and we're looking at the association with PFOA and PFAS and some other perfluorinated compounds in that case. In the Healthy Start study, which we have some of our grantees are involved with, although it's largely funded by the National Institute of Diabetes, Digestive Diseases, and Kidneys, has an ethnically diverse cohort of 800 mother-infant pairs in multiple sites across the country, and is looking at metabolic and behavioral factors during pregnancy. And the Marbles is really a terrific study. This is being conducted at UC Davis, and our grantees there. And in this autism, as you probably know, now the prevalence is 1 in 68 children has somewhere on the autism spectrum, and there are about 4 to 4.5 times more boys than girls that are impacted. So that should be telling us something about the mechanisms, but we haven't gotten very far really to understanding that. But the point is, if you have one child on the spectrum, you have a 10 to 20% chance that another child will be on the spectrum. So that royal we, this is actually at UC Davis and the Mind Institute, they've recruited women who already have a child with autism, and then are following not only that child's development, but they are following subsequent pregnancies, so that they can actually measure what exposures are in the mother, and this child has autism and this child doesn't. So it's a longitudinal cohort. I have to say, these longitudinal perspective cohorts are incredibly powerful. You can really get to cause and effect with epidemiology. A cross-sectional study only tells you that there's an association and really generates a hypothesis for testing, but it can't really show you that the exposure has caused the effect. You can just say they're happening at the same time in a cross-sectional. So in the Marble study is a very powerful study, and we are learning that certain things are highly associated with the risk of autism. We also have the SWAN study, which is a longitudinal study sponsored not only by NIA, but the National Institute of Nursing Research and the Office of Women's Health Research at NIA. But this is, again, a longitudinal study of 3,000 ethnically diverse women, started recruitment in the mid-90s, and these women continue to be followed. And we're looking at the association in following up with perfluorinated compounds there. Now, some of the most powerful studies, and again, I'm just going to keep talking about these longitudinal studies, are the Faroe Islands birth cohorts. I don't know if how many of you know where the Faroe Islands are, but they're kind of a speck of land between Scotland, somewhere off Scotland, but they're part of Denmark, actually. They're up there in the North Sea. They are about 50,000 people, Danish, and Danish by ethnicity as well as heritage and government. But they tend to survive on pilot whale and fish. That's their subsistence, or have been traditionally subsistence. And Philippe Grandjean from Harvard had begun recruiting mothers and during pregnancy in the late 1980s, and he has continued to recruit. So he has a whole series of cohorts that he has been following. The oldest children in some of these cohorts are no longer children, they're in their mid to late 20s, and continuing to follow them. And he's been able to show associations with methyl mercury, associations with PCBs, and now associations where he's been focusing on the perfluorinated compounds. Again, I'll show you some of the fact that he's been the one who was the first one to really show the immune suppression in the children associated with their mother's exposure to both PFOA and PFAS. And when I say immune suppression, about 20%, the children whose mothers were in the top 20% of the population related to PFOA and PFAS were not able to mount a normal antibody response to vaccinations. So I think we have to ask the question, when sometimes we see, we hear about an outbreak of measles or whooping cough somewhere, before we automatically assume that these children weren't vaccinated, we might want to ask the question, well, had they been exposed in utero to something that has blocked their ability to mount a normal immune response? Project Viva is a study that's going on right here, actually in South Boston, but it's a longitudinal birth cohort, again, largely run out of Harvard, and looking at prenatal and child health and neurodevelopment, and again, looking at the perfluorinated compounds in them. Now, to go back to the immunotoxicity issue, NTP is doing some things that are called systematic review. And systematic reviews have been around for a long time in clinical medicine because you know what you gave someone and you can follow what happens. You can do a controlled intervention trial. When you do environmental health, it's very rare that we can actually do a clinical trial. We're not going to intentionally expose something to people to something that we know is bad. Occasionally, like with air pollution, we can remove people from a hazardous place and see what happens to their health. That's a good kind of intervention. But usually in environmental health studies, we have epidemiology studies, which are observational human studies. So we can't control for everything. We do the best that we can. We have animal studies and we have mechanistic studies using, for example, cells or even computational modeling and that kind of thing. And so NTP is developing an approach where you can combine all these lines of data and come up with basically statements about levels of confidence in the data and what the totality of the data is telling you. Unfortunately, some of our regulatory agencies there's some that only want to see the animal data and they ignore the human data, and there are some other groups that only want to use the human data and ignore the animal data. And how much more powerful when we can combine all the information. So that NTP last summer had peer-reviewed and has released a monograph on the immunotoxicity associated with exposure to PFOA and PFAS. And in these studies, they looked at all the data that they can find in human studies, in animal studies, and in mechanistic studies. And basically came up with conclusions for both PFOA and PFAS that they are both presumed to be immune hazards for humans. So the data is the level of confidence in the data and the level of the evidence for PFOA is very, very high in animals and has moderate confidence basically in the human studies. But the antibody response, and I already mentioned that to you related to the Faroe Islands cohort and the PFOA and the vaccination response, but also there's some pretty good evidence, very good evidence in animals, but we don't have the data. People haven't looked as much in humans related to an association between PFOA and asthma. And again, much of this is focusing on early life exposure. So putting it all together, the conclusion was that PFOA is presumed to be an immune hazard to humans, and so is PFAS. But PFAS, again, the data is strong related to the suppression of the primary immune response, so lack of ability to respond to vaccination well in both the animal studies and the human studies, but we don't have any data there really related to the asthma or the hypersensitivity kind of response. So it isn't that the data is negative, it just isn't there. People haven't looked, the questions haven't been asked. So, but it's clear, I believe, that PFOA and PFAS are both having impacts on the immune system of humans. So then the other kinds of studies that we're looking at, the NTP is also looking at a whole number, about 7 different perfluorinated compounds. You have the list up there. For TOX21. TOX21 is the high throughput screening where instead of looking at just a few chemicals and a few different kinds of responses in an in vitro setting, we can look at many. And in this case, we've run 43 different toxicity assays and assays for activation of nuclear receptors. The data is currently being analyzed for this, so stay put. NTP is busy studying all of those chemicals as a class, and they're trying to look at the toxicity and the carcinogenicity of PFOA, the toxicokinetics of a number, those of the PFAS in the Harlan spray dog rat, and looking at it also by in vitro and in vivo models. And I think an important thing here, we've already talked about the persistence, for example, of many of the PFAS is both in the environment and in the body. So you really need to know what's in the body, what's the blood level or what's the tissue level, not just what the administered dose. I've had a really hard time for the last 30-some years helping people understand that when you do animal studies, you have to use a higher delivered dose, so higher, say, drinking water concentration, than people are drinking in order to get the same internal dose. And that's because small animals metabolize chemicals much more and get rid of them more rapidly than big animals, simply. So, often you'll say, oh, the dose to the animals is so high. Well, you gotta look at the internal dose, what actually is in the animal, and often it's not so high. So some of the ongoing NTP studies, we're doing actually a 2-year bioassay for the carcinogenicity of PFOA, where we're actually comparing an in utero exposure and then the rest of the life with no in utero exposure. Because there's growing evidence that, I've actually made the comment that I'm amazed that NTP has done 600 carcinogenicity studies and that we found so many that are positive, given the fact that until 8 years ago or 9 years ago when I came, we were only starting exposures in adults. Well, the critical windows of susceptibility for many things are during development. By the time you get to be an adult, at least a young adult, you're pretty stable. Hopefully. Anyway. So those studies are currently undergoing review, and we expect the pathology tables, the completely peer-reviewed pathology tables, to be posted this summer and the full report out next year. We're also doing 4-week studies to compare the toxicity and the internal dose of those 7 perfluorinateds that I mentioned. And again, that data is currently under analysis. We're also looking at the toxicokinetic studies of all the chemicals, including the A2 fluorotelomere, which is important, and those are being analyzed. The immunotox assessment is actually pretty interesting, and PFDA is the chemical that I actually studied in the 1980s. And again, they are finding that the PFDA is as immunotoxic as PFOA, or not, or possibly even more toxic. And some of that information was presented at the Society of Toxicology meeting last March. And then there is a number of in vitro studies that have been published showing the mitochondrial toxicity and the immunotoxicity, and then some of the neurotoxicity that is shown of these compounds. So right now there are a bunch of studies focusing on the early life PFOA exposure, and we're seeing that there's enhanced weight gain at low doses and reduced weight gain at high doses. Now this is what we call a non-monotonic dose response curve, and for a long time people said, oh, that can't happen. You can't go one direction and then another direction. The point is different things happen at different doses and you have different mechanisms. And something like weight gain is a really gross, no, that's the wrong word, really, I mean, it's a phenotypic endpoint that doesn't really tell you how you got there. And there are many different ways. You can have an animal gain weight because it ate too much. You can have an animal gain weight because it has edema. Completely different mechanisms, and yet both may have adverse effects. But what you find here is that at very low doses, the animals, this is in utero exposure. But then later on, they may get fat. There's also impacts on the liver, and that's been known for this whole class of compounds for a very long time. Impacts on on tumors and inflammation. One of the things I want to mention about tumors is for a long time we were told that PFOA caused liver tumors, and that was due to interaction with a specific receptor protein called PPAR alpha, and that causes peroxisome proliferation. And if you didn't have peroxisome proliferation, you weren't going to get tumors. Well, the answer is wrong. Because in fact, if you take mice and you remove the PPAR alpha receptor, you genetically make a PPAR knockout mouse, and then you treat it, you still get tumors. You don't get as many liver tumors, but you still do get liver tumors. And we now know that as many chemicals don't impact just one nuclear receptor. Receptors are not, we used to talk about a lock and key and think it was very specific. In fact, they're not. They're pretty sloppy. And chemicals can often impact multiple nuclear receptors. And so we know that, for example, that the perfluorinated compounds not only bind to PPAR alpha, they bind to PPAR gamma, which is a receptor involved in diabetes, the diabetogenic response, as well as some of the other nuclear receptors. So I just wanted to make the point that cancer does not require the PPAR alpha receptor, and neither does hepatocellular hypertrophy, so for example. And then we're also seeing impacts on behavioral changes. We know that, and this is really important, PFOA is transferred to the offspring, not only transplacentally, but is also transferred then after birth via the milk. And not only can we actually, Sue-Fenton has actually milked mice and rats and measured the PFOA in them, but we also have done studies looking at mother's milk and found high concentrations of PFOA in mother's milk. We also know that at high doses of these compounds, you can actually block lactation altogether. And I'm going to show you some of the data. And some of that's because these compounds are screwing up mammary gland development. So if in utero exposure, you end up with a mammary gland that is not normal. And Sue-Fenton has really been the leader in this field and developed many different assays and different approaches. But what you can show is that the mammary gland is uniquely susceptible, exquisitely susceptible to these chemicals. And this study, this table I think is just important because what it shows, whoops, I didn't want to go ahead there yet, is that the PFOA associated with the mammary gland effects, the concentrations, and this actually shows days after the PFOA dosing ended, so it gives you some idea of the half-life, for example, in the mice. But the concentrations here, in which we're seeing mammary glands effects in the mice, as low as, for example, 0.1 milligram per kilogram dose, for example, look at the concentrations and look at the serum levels that we're seeing in the Ohio Valley children and their serum levels. Certainly within the same range. For example, children 2 to 5, 600 nanograms per mil. Well, that's up at the high levels, you know, or the bolus levels, for example, of exposure, but even lower. And I guess one other thing that's interesting here that I just want to point out, when we look at the levels in the children, you can see that the highest levels are in the youngest children. I published a paper about 10 years ago where we just were looking at blood levels of 8 different PFAS, and again showed the same kind of thing, and that was just in a random sample kind of children from Dallas, Texas, where we happen to have the serum. But the highest levels were in the youngest children, and part of that is related to lactational transfer, part of it may be related to in utero exposure as well. So this is just I'm a scientist, guys, that people may think of me that I have to administrate a big program, but at the same point I love the science. And just to show you the difference between what we're seeing in a duct in the mammary gland in a mouse that was exposed to a mg per kg of PFOA, and what you can see is a total change in the structure at that level. And then this is another looking at the difference in the size of the animals. Remember I said that PFOA can cause can impact the size of the animals, and we see that in our animals, so that, for example, at the low dose, you get an increase in body weight, and then at the higher doses, you don't see that again. So the non-monotonic dose-response curve. So some of the work that's been done by Sue-Fenton of NIEHS has shown again that the lower birth weights following PFOA exposure, and we see that in not only in animals but in children, that the fact that then later as they grow, by the time they reach about 90 days of age, they tend to overgrow and become overweight, and we're seeing that in epidemiological studies. We're seeing, and it's maybe because of an impact on mammary glands in people as well, but we're seeing in humans that people who have women who have higher PFAS levels nurse for a shorter period of time, and whether that's because they have difficulty nursing, we really don't know, but it's a hypothesis. We are beginning to use this mammary data in risk evaluation. So we heard how New Jersey has actually pointed up how sensitive the mammary gland is to effects. And I think all the liver data that we've seen, it shows that the liver data in the knockout mice shows the human relevance of the effects. We're continuing to do some more work on, now uncharacterized is the wrong word, but a PFAS that we've defined the structure, but we don't know very much about how much, who's making them and so on. But we're looking at these and looking at the effects on adipocytes for lipid production. We're looking at their metabolism by the liver. We're looking at hepatic effects more generally in vitro, and we're looking at the placenta, because that appears to be the placental control of energy and the transport across the placenta appears to be very important in exposing the fetus. And once we identify which of these 22 are the most active, then we'll be going into some animal studies as well. So another thing we do is we work with many of our colleagues. I mentioned biomonitoring, and Haynes is currently monitoring 16 different perfluorinated compounds in the blood of people, a large number. We're also ATSDR, which is affiliated with CDC, is beginning to do health assessments at sites where there are elevated PFAS in the groundwater. So they're doing health assessments at a number of them, and we're working very closely with them on these studies. We've already heard about the Madrid statement that was fostered by the Green Policy Science Institute. And I think I have to say, while I was initially not such a fan of these class approaches, I've become one, because we can't test our way out of 3,000 or 6,000 different chemicals. We have to have an approach. And frankly, every perfluorinated compound that has been studied is causing problems. So I don't know of any that are totally innocuous. And they all, even if they have a shorter half-life, I'll tell you, a half-life in people of 30 days is not a short half-life. And so that means if it's a half-life of 30 days, it's going to build up in your bodies, especially if you have ongoing exposure. And the other point is even if that's a short half-life in the people, in the environment, it's not going to go away. And if you have ongoing exposure to things, even if the half-life is short, you may still have adverse effects. We've seen several slides about acceptable levels, and I was very pleased when EPA dropped what it considered an acceptable level to 70 parts per trillion in May of 2016. That was much better than 400. Would I like to see it go lower? Yes. But I was happy that at least they said it didn't have to be just PFAS or just PFOA. It was if the sum was that. So that was moving in the right direction. Some of our states have lower levels, and I guess I didn't realize that New Jersey was talking about 14. That's terrific. Vermont is down at 20, which is great. And I love this quote from the Minnesota Health Commissioner that we err on the side of caution, and that's sort of the tradition we have here in Minnesota to really protect the most vulnerable as best we can. And so the question is PFAS, PFOA replacements? Well, I think I've already kind of made the point that I don't think they're necessarily better. We tend to go from one bad chemical to another one that we know less about until we start studying it. I mean, some of the new perfluorinated compounds are equally persistent. Their toxicity, we really don't know much if they're less toxic or not. We know very little about how well they're taken up or where they go. And we know, and we saw some data a little bit before, that many of, for example, the shorter chain ones are not removed by carbon filtration in your water system. So that's another problem, that they're going to be harder to actually get rid of. So NIEHS and NTP are working very closely with all of our federal partners. We've actually been having a series of meetings and calls to have a coordinated research approach and to make sure the information is shared. We're also working very closely with the Department of Defense, because the Department of Defense has all the Army and Air Force and Marine bases and stuff where lots of the AFFF have been used and are an issue. So with that, I say thank you very much. We are redoing our strategic plan. It's been 5 years unbelievably, so we're starting again. We're looking for your great ideas. If you go on our website, we'd be very happy if you give us any of your ideas for future work. So thank you very much. Okay, so if there's burning questions, happy to answer them. I'm going to be here almost for the entire meeting. When they tell me I can do science, it's like, yes. Okay, thank you.